Next speaker is Karen Christensen, and she is the Bayren Codes and Standards Program Manager at the Metropolitan Transportation Commission. We're very lucky to have Karen step in to give this talk on energy efficiency in existing residential buildings and why does it matter. Oh, I don't have an intro. I'm going to put you right there. Thank you, Karen. Not sure. There you go.
Morning. Thank you all for coming out this morning to talk about energy efficiency and residential buildings. I'm going to just be setting the stage for the rest of our speakers as to why this is important, why this is a topic that we wanted to spend a little bit of time. Although since you're all here, are on board, so maybe this will help some ammunition if you need to convince them. Talking about existing residential buildings today, we're talking about single-family homes and also multifamily buildings. Most of the ones here in the Bay Area have natural gas for space heating and water heating, and electricity for lighting, and everything you plug into the wall, plug load. Our existing buildings here in the Bay Area tend to be older. Almost 7 out of 10 single-family homes and 6 out of 10 multifamily buildings are older than 1978, which was when first adopted its energy efficiency standards. So those older homes don't have many of the efficiency or techniques that we've developed in the years since then. Some of the things that they don't have that you might find in a newer building are more efficient lighting, like LEDs. Sorry, I thought it was. So some of these older buildings might not have LEDs. They often, back up one, another thing that is a common problem in older buildings is they need air sealing. They have places around the doors, the windows, the joists where the air can flow in and out, whether you want it to or not, regardless of what the temperature or the air quality might be outside. Another thing that you can do to improve your efficiency in an older building would be to replace the efficient versions. Water heating and space is almost half of the energy in an existing building, so this is a way to get a lot of for a couple of relatively small projects. And if you opt to do that with something like a super efficient heat pump water heater or electric, you might you might opt to put solar panels on your house, for example, to add to that. Something that is much harder, though, would be adding insulation to inside your walls or to your ceiling and your floor. So there are certain things with all of this that are really much harder to do to an existing building, and that's my way to put a plug in for something that we're not really talking about today. But if folks are not thinking of doing a REACH code or helping to make sure that your new buildings that are built are as efficient as possible, please give that some thought, because otherwise we'll be looking to retrofit those buildings in a few years. So, and I'll get back to the existing building hat. Just a quick question for the room. How many of you all live in buildings that are older than, were built prior to 1978? I know I do. Okay, so many of us do. And one of the other problems with those older buildings is that they don't change all that fast. About 1% of buildings are renovated every year. So that's 1 out of every 100. That means it takes about 100 years to renovate all of the existing buildings. We don't have that kind of time. So that's part of the problem. And as a result, 2 out of 3 existing buildings that exist today will be around in 2050. We can expect that. Those existing buildings use almost 18% of the energy here in California and produce about 1/4 of the greenhouse gases. As you can see, California has very ambitious greenhouse gas reduction goals. I think everyone's familiar with that. And you can see the 2050 goal is way down there at the bottom. 2 out of 3 of our existing buildings will be around then in 2050. So we will need to address those if we have any hope of meeting that goal. But greenhouse gases are not the only reason to improve your building's energy efficiency. If you have a building that is more energy efficient, it saves money in the long run. It costs money to put in those energy efficiency measures, but you will save money on your energy bills the whole way through. You will also have less impact on the energy infrastructure and peak loads. Those of you who are familiar with the duck curve know that there's a peak in the afternoon when we don't have so much solar energy generation, but we do have a lot of demand. And that peak load, one of the best ways to address that is to just have less demand in the first place, and that's what energy efficiency can help to do. In addition, energy efficient buildings are more resilient. These graphs are from a study that was done in New York. So the climate's a little bit different, but you can see that during a winter blackout, if energy is disrupted in a typical building, the temperature goes down much faster than in a high-performing building. And the graphs on the bottom of the screen show for a summer blackout the same sort of thing, well, the reverse really, that the temperatures will stay lower and more comfortable for much longer in a high-performing building than in a typical building. And I think here in California, that's particularly relevant because we have the possibility of disruptions due to earthquakes, and as well as to rolling blackouts and other types of events such as that. So why make buildings energy efficient? I think the question really answers itself. There are many, many good reasons to do that. But there are also some challenges for making buildings energy efficient. One of the key ones is money. All of those things, you do have to put money in up front to build or to retrofit an existing building. People might not have that money. People might own property but might not have the money to put $2,000 or $10,000 into improving their house at this point. Prioritization is another problem. Even if they have the money, they might have other things that are priority. They might have kids that are going to college. They might have retirement pending. They might have all sorts of demands on their resources. So it might not be a top priority for the property owner. And then another factor is the complexity, because our existing built environment is very complex. The buildings are built with a wide variety of designs, construction types, and as a contractor friend of mine once said, once you open up the walls, you never know what you're going to find in there. So projects, if any of you have done construction projects, you might know sometimes it starts as one kind of project and then some other things need to happen along the way when the contractor finds something else. So all of those are some of the challenges that we're going to be facing as we start trying to crack this nut of existing buildings. And I'm looking forward today to hearing from our other speakers about what they might, the approaches that they have taken to addressing existing buildings, to start to look at this and start to take action at the local government level on this problem. So, I forgot I had those arrows in there. There we go. That's my information, some general background, just set the stage for all of us, and thank you very much.
Great. Does anyone have any questions for Karen? We have a couple minutes before the next speaker, if there's any.